Greetings and salutations. Welcome to a video on expanding algebraic expressions using the distributive property. So we have some of our regular terms here, some key vocabulary. We will be using this word, term, quite often, coefficient quite often, and then this is our new one down below here. So the distributive property allows us, or is when you are evaluating an expression, by multiplying each term in the parentheses by a factor, which is usually listed before the parentheses. So I notice I have two different spellings of parentheses here. So let's check and see what this actually looks like in practice. So we'll start out with a word problem because I think this helps illustrate the idea here. So Mr. Plaska has 2 boxes of cookies. Each box contains 5 chocolate chip cookies and an unknown number of snickerdoodle cookies. How many total cookies does he have? So I'm imagining if this is one box here, in this box I have 5 chocolate chip cookies. I'm going to actually use a different color for that. 5 chocolate chip cookies for that. And then an unknown number of snickerdoodles. And so I'll make those S. So there's one box of cookies. I'm not going to use S because that looks so much like a 5. I'm going to change it to a C for cookies. Sorry about that. So in that one box I have 5 cookies and then C cookies, but I actually have 2 of those boxes. So I'm going to duplicate that because here I have 2 boxes. Now, if we're trying to figure out how many total cookies I have, we're going to need to find out how many are in one box or combine these all up. So I'm going to do one bar here. Give it a black pen. And so in this, I'm going to rearrange my terms so that way both of my 5s are next to each other, and then both of my variables are next to each other. This way, it's basically I am combining like terms. So visually here, it's like I dumped out all the cookies and I stacked up and organized all of the chocolate chip cookies and then all of the snickerdoodle cookies. And the math to figure it out now, I can do 5 plus 5 plus C plus C. 5 plus 5 is 10. C plus C is 2C. So he has 10 plus 2C cookies. Oh my, oh my. That's a mess. Okay, cookies. Now, this is fine if you only have 2 boxes and your expressions are relatively simple. So we're going to look at how we would model this with an algebraic expression. So I'm going to shrink this down a little bit and then give myself some room here. So if I pull this back down here, this shows in one box we have 5 plus C cookies. In your next box, you also have 5 plus C cookies. So this means here we have 2 groups of 5 plus C cookies. Now I know groups, when I say groups of, that tells me multiplication. And so what we have is 2 times 5 plus C. And in algebra, we would write that as 2 right next to the parentheses, like that. So all of these things, this is equivalent to this, which is equivalent to that. And all of this is equivalent to if we combined those like terms using addition. But with algebra, we don't do that. Instead, we use multiplication to make our lives a little bit easier by using the distributive property. And it's important to note that with this, we have 2 groups of this whole amount, of that 5 plus C. It's not just 2 groups of 5, it's not just 2 groups of C, it's 2 groups of both of them. And because we're doing 2 groups of both of them, we can rewrite this using multiplication, where we essentially distribute or pass this 2 out to both of the terms. So we have 2 groups of 5, and we have 2 groups of C. And now that I've written that out, I'm going to combine like terms, and I'm going to do some evaluating here, some simplifying. 2 times 5 is 10, and 2 times C is 2C. So if you notice, check it out, here's our answer there, and it matches our answer up above. With the distributive property, it's really important that you make sure that you distribute this to everything inside of the parentheses. Because according to our picture, we have 2 groups of 5. There's one 5, there's the other 5, and we have two groups of C, so we need to make sure we do 2 times both of them. Let's look at this in another example to see how this goes. So here, in my head, I am thinking that I have 3 groups of 2x plus 1. And so I could think of this where here's x, and there's 1. And I have that 3 times. Boop. Duplicate, duplicate. Okay, so I have that there. Now, if I were to use our model to regroup this, I notice there's 1x, 2x, those ones. Then I have 2 more from there. And then I have 2 more from this final group. And in this last bit, we have the 1s, 1, 1, and 1. So I'll quick highlight to track where those are coming from. So there's an x from the group 1. Here's 2 more x's from the second group. And here's the final 2 x's from there. So in the end, we have 6x plus 3. Now, that's obviously not the most efficient way, but that's just showing how this distributive property works. We have 3 groups of 2x. This is 2x. That's 2x. And that's 2x. And then we have 3 groups of 1. So let's look at this algebraically. We need to distribute that 3, that out in front, to both of the terms. So we have 3 groups of 2x, or 3 times 2x, plus 3 groups of 1. 3 times 2 is 6x, plus 3 times 1 is 3. And it is very important that we keep this variable there, because that variable, if you notice, it shows up all through here, and we can't just get rid of it. Now, that is our answer. Here is our final answer, that 3 times 2x plus 1 is 6x plus 3. So I'd like you to take a moment and pause the video on this question here and see, can you do it by yourself before I go through and solve it? All right, so let's see. I'm going to distribute this 4 to both terms. So first I'm going to do 4 times 1, or 4 groups of 1. And now I need to do 4 groups of 3m. Simplifying, 4 times 1 is 4. 4 groups of 3m is going to be 12m. Now I am going to do a quick picture to see how did I do. So if this is one group and it contains 1 and 3m, and I'm going to do that 4 different, oops, let me grab this. I'm going to do that 4 different times. 1, 2, there's our 4. So we have 1, 2, 3, 4. And then we have 3, 6, 9, 12, 12m. So it looks like our model matches our work here. We have 4 groups of 1, and we have 4 groups of 3m. And that does equal 4, and this does equal 12m. So I should feel pretty confident in this. All right. Now I notice we have a term here, an expression that we need to distribute, and then we need to combine like terms. So you always want to make sure you distribute first, and then you're going to combine like terms. Because we don't have 2 groups of this whole thing, we only have 2 groups of n plus 2. So mathematical speaking, we'll go like this. 2 groups of n plus 2 groups of 2 plus 3n. 2 times n is 2n plus 4 plus 3n. Now I notice we have 2n and 3n, so I am going to rewrite those. 2n plus 3n plus 4, and that equals 5n plus 4. I'm going to do a quick model because this is a new type of problem. Here we have n and 2, and we have that 2 times. Duplicate. And then we have an additional 3n. So n rid of those lines. This is 3n. So if we were to count these all up, we have 1n, 2n's, plus 3n's equals 5n's, and then 2, 4. 5n plus 4. Check it out. That's what we got. So our model matches our math there. Now things do get, a little bit more complicated when you're dealing with subtraction, but it is very doable. And since we haven't worked with the integer operations or multiplying and dividing by decimal or by negative numbers, I am going to continue to think of this like it is subtraction. So again, we have 3 groups of 2 minus 2x, and then we are going to be taking away another x after that. So let's do some distribution and then combine like terms. So we have 3 groups of 2, and then we are subtracting 3 groups of 2x before we subtract another x. So let's simplify. 3 times 2 is 6. We're subtracting 6x, and then we're subtracting another x. So because we're subtracting 6x and then we're taking another x away, we are actually going to be subtracting 7x. And that seems to be reasonable. I spend 6 times the amount of money, and then I spend 1 more of that time. I'm going to be spending 7 of those times. So just keep in mind as you're going through this that track when you're subtracting, what you're subtracting, how much of it you are subtracting. And when in doubt, model it out.